All right, so if I look at this trig identity, the left side is a bit more complicated. So I'm going to work on the left side, try to simplify it and make it similar to the right side. Now, if I look at the left side here, I have one denominator, but on the right side, I have one denominator here and then another term over here. So I'm going to start by splitting this denominator. Once I split the denominator, I notice I can make simple simplifications. I can take out sec squared here and turn this into a square. So I have sec square x over tan square x here. And over here, I can again take out the tan square and get rid of the 4 and turn it into 2. So I have plus tan square x over sec square x. Next thing I want to do is I want to simplify these. So I'm going to start by just writing them using a divide sign. And now I'm going to convert everything to sine and cos, because if I look at the other side, I have sine and cos on the other side. This is 1 over cos square x divided by sine square x over cos square x plus sine square x over cos square x divided by 1 over cos square x. I'm going to turn my divides into multiplies and flip my fractions. We'll do the same thing over here. And now these are multiplying, so I can cancel the cos square and cos square here, and over here I can also cancel the cos square and cos square. So I'm left with 1 over sine square x plus sine square x over 1, which is just sine square x. Yeah, this is kind of similar to this, but still not exactly the same. We're getting close though. So I'm going to just start. The next thing I'm going to do is I'm going to make a common denominator. So I'm going to multiply the top and bottom here by sine square x. And the reason I'm doing this is because I'll get a sine 4x. And when I have a sine 4x, I can easily convert that to cos 4x later on. So I'll multiply the top and bottom here by sine square x. So I have 1 over sine square x plus sine square x times sine square x over sine square x, and this is nothing but 1 plus sine 4x over sine square x. Now I want to create a cos 4x from a sine 4x. So in order to do that, you can turn this into 1 plus sine square x times sine square x. It's actually going backwards a step over sine square x, and now I can replace each sine square x with 1 minus cos square x. The next thing I'm going to do is I'm going to FOIL out this bracket over here. So I'll start by going continue over here. 1 plus 1 times 1 is just 1. 1 times negative cos x is minus cos square x. Negative cos square x times 1 is negative cos square x, and negative cos times negative cos is positive cos 4x. Denominator is still exactly the same, sine square x. Now I can simplify this. This is 2 plus, minus 2 cos square x plus cos 4x divided by sine square x. So now we're almost at the solution. I know that my first term here is cos 4 over sine square x. I'm going to take this cos and this sine. I'm going to write it at the start. So cos 4x over sine square x And then I'll just add on this term, so plus 2 minus cos square x over sine square x. So the reason I did this is because this part here is now exactly the same as this, which means that this whole part here should be converted to a 2. And there's a 2 over here as well that I factored. So the next thing you want to do is you want to common factor out a 2 from the top over here. So this stays the same. One minus cos square x over sine square x. And we know 1 minus cos square x is just sine square x. So I have plus 2 sine square x over sine square x. And now I can just cancel the sine square x, and this is my final solution, which is basically the exact same as the other side.